So you don't have to write out all the transformation rules. I made this as a notebook kind of resource page for you. So this is in the new packet I handed out. I'm jumping ahead to 304 because it ties directly in with that exploration that you did. So look, I've written down the transformed quadratic equation for you and what it would look like. So moving it to the right and moving it to the left. Inside the parentheses, -2 or +2. So you've got this resource to continue to look back on, summarizing what we did on that exploration. This is page 304. So then this is your up and down. The x squared +2 shifts it up, and the x squared -2 shifts it down. So that way, if your handwriting is not as good, you have this as kind of your all 8 of your transformation rules summarized for you. And if you look at the back page of 304, there's nothing that you need to write down. Here's how you flip over the x-axis or the y-axis outside the function or inside the function. These are for quadratics. So we didn't just do quadratics. That was part 1 of that exploration. And then this is your vertical shrink or stretch, twice as steep or less steep. So to me, this is kind of your 8 different transformations. That's going in your resource section after this unit so that they're all written down for you for your final exam. But what I wanted to do today is let's practice writing out some equations with those transformation rules so they start to sink in. Because if you do something 21 times, it's supposed to sink in. So like doing a vertical shift, we just looked at it twice. Once on part 1 and once on part 2. Now we're going to look at it again with cubic functions and again with absolute value functions. So we've done it 4 times, right? So by the end of this unit, you'll have done it at least 21 times. This plus constant should sink in. So if I want to transform x cubed, we don't know what that looks like because I skipped the parent function page for now. But any function, no matter what it is, if you want to move it up, I'm going to write y equals, but you know that y equals is the same as f of x equals, right? I'm going to write y equals x cubed. How far do you want to shift it up? Give me your favorite number. All right, we're moving it up 7 units. So y equals x cubed plus 7 would shift it up 7 units. Or y equals the absolute value of x plus 7 would shift it up 7 units. So running the 7 outside of the function, outside of the x cubed, outside of the absolute value, it's the same for any function. Are any of you in trig right now? So you will graph trig functions. So it's the same for trig functions. Sine of x plus 7, x squared plus 7. All right, if I want to go down vertically, you know vertically is up and down, right? So this one would just be y equals, someone give me their favorite number. My favorite numbers? All right, x cubed minus 9. All right, that's going to shift the whole function down 9 units, or absolute value of x minus 9. So up is on the outside, down is on the outside. And then right and left is inside the parentheses, and I told you it's kind of backwards, what you think it means. To go to the right, we actually have to subtract a number. Remy, what's your number in sports? What is it? 33. So we're going to go right 33. So y equals parentheses x minus 33 cubed. So I'm putting my function x cubed on the outside of this parenthesis, and that will move me right 33 units. Or I could write the absolute value of x minus 33 absolute value. So that shifts me right 33 units. Oh, and what's your birthday day of the month? 11th. So we're going left 11. So y equals parentheses x plus 11, and then we're cubing this function. like we would square it if it was a quadratic. We're cubing it because it's a cubic. So that would shift me left 11. Y equals absolute value of x plus 11. That's absolute value. That V-shaped graph shifted left 11. So if you are a flashcard person, to me, this lends itself to flashcards. So like on one side of the flashcard, you would write like this function down, and on the back side, you would write the words like up 7. Or you would write this function down on the front side of a flashcard, and on the back side, you would write right 33. So there's 8 transformation rules to memorize. You need to have them memorized. And if we look ahead, when was I going to do a quiz on, I was going to do a quiz on Friday on transformation rules. So we're using transformation rules. We did it Friday on the exploration, Monday, Tuesday, Wednesday, Thursday. You'll have done 3 homework assignments. We're quizzing on Friday on those transformation rules. So a really good practice would be to make some flashcards for yourself. All right, then we're going to flip it upside down and backwards here. So if I want to flip over the x-axis, that's upside down. I put the negative in front of the whole function. Y equals negative x cubed. You don't need to put a parenthesis, but if you really want to, the negative would go in front like that. So if you want to put parentheses, you could. They're not really doing anything in this case, but that both flips it upside down. Or y equals negative the absolute value of x. So that's upside down. If you want to write x-axis is upside down. And then over the y-axis, that's when you're going to see it sometimes and not see it other times. It's inside the function. So it changes all your x values and makes them negative. And like I just said before, this one you're not going to see any change. The x cubed function you actually will, because x cubed looks like this normally. We're going to see that parent function. So flipping it over the y-axis shifts it this way. So this kind of S-shaped graph is going to get flipped. That's kind of hard to see. This would be the transformed function. So red is original and black is transformed. All right, and then I need someone else's favorite number. Justice, did you already give me a favorite number? Give me a favorite number. 1,000,000. No, what? 5? All right, we are going to do a vertical stretch 5 times as steep. So y equals 5 times x cubed. It's not the slope. For a linear function, it would be the slope, but it's the steepness of the curve. In absolute value world, it actually will be the slope because absolute value is a linear type function. So it's going to make your slope of 5, your V-shaped graph. All right, and then give me your favorite fraction. It has to be less than 1, like a half, a seventh, a fourth, 3/4. Half is easiest. So we want to do half of x cubed or half of the absolute value function. So just looking at, we're going to have 8 different types of parent functions: linear, quadratic, exponential, absolute value, cubic, square root. The transformation rules are the same for each one, and you have to be able to write them correctly. So for the last couple minutes, what I'd like you to do is this back page, 1 through 14. Each one should take you about like 30 seconds or so. Like this one has 2 different transformations happening. So what would the 4 do to the function, and what would the 6 do to the function? Can you tell me real quick, number 1, how I would answer that? What does a plus 6 do? What transformation was that? There's no parentheses though. So it actually is moving the whole function up 6 units. What would a 4 do multiplying it in front? It was the last one we just did. It makes it steeper, right? Or a vertical stretch times 4. Let's do one more together. How about 3 underneath it? What two things are these guys doing to the function? Am I moving up, down, and left or right? You can use your kind of cheat sheet that we just did. So the 4 moves it to the right 4 and up 5. Does it kind of make sense how to go through that guided practice? All right, so you are doing the guided practice.